Okay, so today we're talking about parallel lines and proportional parts. Proportional parts, of course, being in triangles and parallel lines. So the goal of the day is for you to be able to use proportional parts within triangles and to be able to use proportional parts with parallel lines. Our only definition per se will be the mid-segment of a triangle, which we'll get into that later and exactly what that means. So our first theorem is the triangle proportionality theorem. And so what this says is that if a line is parallel to one side of a triangle and intersects the other two sides, then it divides the sides into segments of proportional lengths. So what that means essentially is you could set up a proportion to find out missing side lengths. So like, for example, let's say AB has a side length of 4 and BC has a side length of 1, and then ED has a side length of 2. So essentially what this is saying is, okay, AB is 4 times as big as BC, which means AE has to be 4 times as big as ED. So we would be able to find out that side AE would be 8. And this would be done by setting up a proportion. So how we would set up that proportion is we would say, we'll set it up just like they do first, and then I'll show you how I set it up just because I'm particular. So they said AB over BC equals AE over ED. And so then if we substituted in our values, we would have 4 over 1 equals X, I'm just going to say unknown, over 2. And so how we would go about solving this, there's a number of ways to solve proportions. The way I like to do it is I like to cross multiply. So what I do is I multiply 4 times 2, which would be 8, and 1 times x, which would be x, so I would know x equals 8. Some people like to do what they call cross canceling, and then they cross multiply. And what that looks like would be, let's set it up again down here in blue. So we would have 4 over 1 equals x over 2. So what that would look like is they would say, okay, we have a 2 on the bottom and we have a 4 on the top, so I can divide both of those by 2, which would leave me with 1, and this would leave me with 2. And so nope, I'm messing that up. This isn't the cross-canceling one. I forget where cross-canceling is. Oh well. Oh, cross-canceling is when we're multiplying and dividing fractions. Ignore my stupid comment. So anyway, cross multiplication. That's the way to do it. So the only difference I would have done here is, personally, when I set these up, I like to do the smaller side on top. So I would say BC over AB equals ED over AE. And that's just a personal preference thing. I know it seems kind of ticky-tack, but I just prefer to do it that way. I don't really know why I prefer to do it that way. I think it's because when I cross multiply, I go from the bottom right up here and I say, okay, 1 times x, so this side's going to be x equals 4 times 2, which would be 8. That's just how my eyes work, and then that sets up the x on the left-hand side, which I prefer, but you can solve it either way. But essentially what this triangle proportionality theorem is saying is just you can set up a proportion to find missing side lengths. They're all going to be proportional, so they're going to be in the same degree. All right, so our first example here, we have in triangle RST, RT is parallel to VU, and then they give us all these different side lengths. So what we can do is we can set up a proportion. So to find the missing x. So I'm going to say SV over VR equals SU over UT. And once again, you can flip this whole thing. So you could also say VR over SV equals UT over SU. It's totally your choice, but personally, I'm going to do it this SV over VR way because that's my personal preference. So I'm going to say 3 over 8 equals x over 12. Okay, so now I'm going to cross multiply. 3 times 12 is 36 equals 8x. So I would solve that. I would say x equals four and a half. X equals 4.5, I suppose, right? As long as I write that 8 appropriately. Let's just double check that with the calculator because it's early and my brain's not working great. Yeah, it's 4.5. So X equals 4.5. And just for my own. Yeah. Yep. So X equals 4.5. All right. So we're doing the same deal for this one. We have our triangle. We have our parallel lines here, which means we can set up a proportion. And let me go back one. So what I did here, I set up the proportion and then substituted values in. So I set it up and then I plugged in values. If you want, you can just go straight to it and say, okay, 4 over 10.5 equals 6 over x. That's totally fine. I just did it that longhand way the first time just to kind of show you how you would set it up. But if you prefer to just do it this shorter way, feel free to do it this shorter way. So we cross multiply, we get 4x equals 6 times 10.5, which I believe would be 63. Yep, 63. Then we divide by 4 on both sides to keep the equation balanced and happy, and we get x equals 15.75. Delightful. All right, so now we have our second theorem. So this is just the converse of triangle proportionality theorem. And so essentially what this says is if our segments are proportional, then these lines are parallel. So like let's just say this was 2 and 4. And this was, you know what, that doesn't make sense. Let's do 3 and 6. And so let's say this is 2 and 4. So if we were to set this up as a proportion, we would have 2 over 4 equals 3 over 6. And then we would cross multiply these and we would get 12 equals 12, which checks out. That's perfect. Yeah, so 12 does equal 12, so that checks out. So they are it's an accurate proportion, which means that these lines are parallel. So we're essentially doing it backwards. We're saying, okay, if this proportion is correct, then these lines are parallel. Now, if you had something like, let's just say, let's change this. Let's say this was a 5. So if you had 3/6 equals 2/5, what you'd end up with is you would end up with 15 equals 12. So that would not be an accurate proportion because 15 does not equal 12. So that would mean these lines here are not parallel. That's all this converse of triangle proportionality theorem is saying. So we're essentially, what they call this is it's kind of like an indirect proof. So they're asking us to determine whether line GH and FE are parallel. So in order to do that, we can say, well, let's label first. So essentially, if they're parallel, our reasoning is going to be the converse of triangle proportionality theorem. So they tell us DH is 18, HE is 36, and then DG is 1/2 of GF. So this is GF, and this is 1/2 of GF. Okay. Sorry, I'm losing my train of thought quickly. Okay, so if I were to set up a proportion, now stick with me here because this does get a little confusing. So I have 18/36 for one of them, and then my other one would be, instead of saying GF, I'm just gonna say X because it works better for me. So we have 18/36 equals 1/2 X over X. And so this one's a little bit tricky because we don't have values on both sides. But if we simplify this left side and we reduce it, we could divide the top and the bottom by 18, which wouldn't change anything. So we would end up with 1/2. So we know the top is half the bottom, or the bottom is twice the top, which if we look on this right hand side, we have 1/2 X over X. So the top is half the bottom, and then the bottom is twice as big as the top. So we would say, yes, these are parallel. So GH is parallel to FE because converse of triangle proportionality theorem. Converse triangle proportionality theorem. Please, please, please abbreviate. Do not write it all out. That would be ridiculous. Okay, so now this one should be a little bit more straightforward. So they say in triangle WXZ, XY is 15, YZ is 25, WA is 18, and AZ is 32. So we need to determine whether WX and AY are parallel. So like we've been doing, we'll set up a proportion. 18/32 equals 15/25, and then we cross multiply. So let me say this. We can cross multiply, which is the way I always do it. So I would say 18 times 25 equals 450, and 32 times 15 equals 480. You can also reduce these if you prefer. So I could say, instead of saying 15 over 25, I could say 3 over 5. And then instead of saying 18 over 32, I could say 9 over, hit it with your hand again, 9 over 16. And both of these are in their most reduced form, and I can see 9 over 16 doesn't equal 3 over 5. So I know they're not going to work. For me, it's easier to just cross multiply and get regular numbers, but if you prefer to simplify and see if they're the same that way, you can do it that way as well. It's really dealer's choice. We would say, no, they're not parallel lines. Okay, now triangle mid-segment theorem. So triangle mid-segment theorem says a mid-segment of a triangle is parallel to one side of the triangle, and its length is 1/2 the length of that side. So essentially what this is saying is if JK, this blue line in the middle, if that's a mid-segment, then it cuts FH in half, it cuts HG in half, and then it itself is 1/2 as big, or it's half the length of FG. So it just cuts the triangle into halves pretty much. So like if FG was 4, that would mean JK would be 2. So a triangle mid-segment pretty much just cuts literally everything in half. All right, so now we get to the application of this. So in the figure, DE and EF are mid-segments of triangle ABC. Find FE. So right away, if they're both mid-segments, we know this and this are the same, this and this are the same, and then we also know 2 other things. We know line FE is going to be half as big as 18, so it's going to be 9, and then we know ED is going to be half as big as AB, which means both of these are going to be 5, or the whole thing is going to be 10. Okay, now they're asking us to find FE, so we did that in me labeling literally everything. So 9 units. Now, in our next one, they want us to find the measure of angle AFE. Now, this is a little bit trickier. Now, once again, I'm just going to go through and label everything real quick. We know these 2 are the same. We know these 2 are the same. We know this is 9. We know this whole thing is 10. Now, in mid-segment theorem, it also says that the lines are parallel. That's another important piece here. So we know line ED, I'm going to do my best to draw this, this line, and I'm just going to extend it because it'll help us see how we find the angles here. So we know this line is parallel to this line. So if we have 2 parallel lines that are cut by this transversal, once again, I'm just extending it so we can see it better. So we have 2 lines cut by a transversal, and we're trying to find AFE. So we're trying to find this angle right here. Now, we know this angle is 87 degrees, and if we have 2 parallel lines cut by a transversal, we can see this 87 degrees and this unknown angle are both on the interior, and they're on opposite sides of the transversal, which means AFE, angle AFE, would also be 87 degrees. And if we needed a reason for that, we would say alternate interior angles. So mid-segments of triangles are not wildly difficult, but there's a ton of ways that they get applied. So it's a lot of problem solving using your definition. So when you write this down, I would make sure you write this in a prominent place, because you're going to want to explore different aspects of it, because you'll end up using it in a whole bunch of different ways. So we used it here to find a side length. Nope, I accidentally skipped that one, but that's all right, because we know AB equals 10, because we found every single measure in this one. So we used it to find side length, line segment length, an angle measure. Here we're trying to use it to find a side length again. So there's just a ton of different applications. So we'll go through a few more examples, but just know that there's going to be some problem solving involved in this. So in the figure, DE and DF are mid segments. So DE is a mid segment, which means DE is the same, that means it's half of AC, so it's going to be 7.5. And then DE and DF are mid-segment, or DF is a mid-segment, which means this is going to be 16. And they want us to find the side length of BC. Oh, we just did that. Lovely. Okay, cool. Now, once again, though, if these are both mid-segments, then that means that they cut. Let's go back. Did I go too far? So that means they cut the triangles in half as well. So if we look at this, that means this and this are the same, which also means it's the same as this. And then likewise, 8's the same as these two. So you get 3 congruent segments anytime you have a 2 mid segments, or a mid segment. All right. So now our final piece, proportional parts of parallel lines. So what this one says is, if you have 3 or more parallel lines and they're cut by 2 transversals, then they cut off the transversals proportionally. So essentially what this means is these are all in proportional pieces. So let's use their example. So they say AB over BC equals EF over FG. So if I give some values to this, so let's say this is 2 and this is 4. Let's say this is 1.5 and we wanted to find FG, you would just set up your proportion again. So you would say 2 over 4 equals 1.5 over question mark. Then we would cross multiply. So we would get 2 times question mark equals 6. Then we would divide by 2. We would say FG would be 3. So it's really just setting up more proportions. So they say in the figure, Larch, Maple, and Nuthatch streets are all parallel. So these are all parallel to each other. And then they want us to find x. So that's lovely. They've given us everything we need. We know 13 over 26 is going to be proportional to 16 over x. Then we do our little cross multiplying. We get 13x equals 16 times 26, which I'm using a calculator for because Mr. Wright's not trying to do that math this morning. And so we end up with x equals 32. Lovely. And if you wanted to reduce this left side and say, okay, well, 13 over 26 is the same as 1 over 2, and then cross multiply, you could do that too, just to make life easier. Personally, I just plug it in and go for it. All right. Oh, okay. So congruent parts of parallel lines. So if 3 or more parallel lines are cut off into congruent segments on one transversal, then they cut off into congruent segments on every transversal. So what this is saying is if A is congruent, or if AB is congruent to BC, then EF is also going to be congruent to FG. So it's really just the same thing as the proportion, except for we're skipping the step of writing the proportion. So in this case, let's just say this was 2 and 2. So they're saying, and let's just say this was 3. So what they're saying is 2 over 2 equals 3 over x being unknown. And if the left-hand side's the same, then the right-hand side has to be the same. Because if we reduced this to 1 over 1, then we would know the top and bottom are the same, so the top and bottom have to be the same on the right as well. So this is really just saying if you have 3 or more parallel lines cut by transversals, and on one transversal you have 2 congruent segments, then you have 2 congruent segments on the right-hand transversal as well. That doesn't mean the right and left-hand transversals are going to be congruent, but just in general, they're going to be congruent. All right, so now we have our example here where they say we can see we have 2 congruent segments on this top transversal, which means we have 2 congruent segments on this bottom transversal. And we're supposed to be finding both x and y. Now, in order for us to do that, what we're going to have to do is we're going to have to set our x's equal to each other and our y's equal to each other. Since we know 3x minus 7 is the same as x plus 3, we can set those equations equal to each other and solve them. So end up with 2x equals 12, x equals 6, and then we can do the same thing on the bottom. We know 9y minus 2 is the same as 6y plus 4. So we would write that into an equation, and then we would solve for y. And so we would get 3y equals 6, y equals 3. So our answers would be x equals 6 and y equals 3. All right. I guess we'll do this last one. It's the same deal. So we know these are congruent. So we would set these equal. We would say 4a minus 5 equals 3a plus 6. And then we would say 3b equals 5/3 b plus 2. So let's solve the a's first because they're going to be easy. A equals 11. Now we go to solve this. We would subtract 5/3 b, which would leave us with, what would that be, 4/3? 4/3 b equals 2. And then we would divide each side by 4/3, which would be the same as multiplying by 3/4. So b would equal 6 over 4, or 1.5. And that would be our answer. Okay, so this was 7.4. 7.4 I know is a lot of information, take your time, go slow, take good notes.